Hi. Let's have a look at this, Jemima, to help you out with this question. So we'll do it on the right hand side here. We've got some carbon, which is solid at standard uh, conditions, and we need two molecules of chlorine gas, which at standard conditions are uh, gas, and that's going to make carbon tetrachloromethane. That would also be known as CCl4, and standard conditions is that's a liquid. Okay, and the question is, what is that enthalpy of formation? Okay, so let's call it delta HF, and that's a question mark. Okay, that's what we're trying to find out. What do we know? Well, we really want atoms at the bottom. Okay, so we want to make these reactants, the carbon and the chlorine, into atoms. Okay, so let's draw a line from the standard states into gaseous atoms. All right, so that's what we want. We want gaseous atoms at the bottom. Okay, so to go from carbon solid to carbon gas, the question tells us that that is 715 kilojoules per mole, and we've only got 1 mole, so there it is, 715. And to break the bonds in the chlorine molecules takes 242 kilojoules per mole, but we've got 2 moles, so that's going to be 2 times 242. And after we've spent that energy breaking those bonds, all right, we would end up with 4 gaseous chlorine atoms. All right, so which is what we want. And if you do that sum, it comes to 1199. 1199 kilojoules. Okay, so now we're going to want to turn this into gaseous atoms as well. But you notice it's a liquid, right? So first of all, we need to do a little step, which would be to turn it into tetrachloromethane gas. Okay, so CCl4 gas. And in the question, it tells us that is 31 kilojoules per mole to do that. So that's obviously to turn a liquid into a gas, it takes energy. That's an endothermic process. That's why it's positive. Okay, and now once we've got gaseous tetrachloromethane, we can break the bonds. Okay, so this here, let me draw it in a different color just to. Right, so we've got carbon and we've got 4 chlorines in tetrachloromethane here. This is it here. And we want to break these bonds, right? So we're going to break that bond, break that bond, break that bond, break that bond. That takes energy, right? To break bonds. Breaking bonds is an endothermic process, endothermic positive energies. So, and each of those bonds is 338, and we've got 4 of them. So we're going to have to say 4 times 338. And that comes to 1352. So it takes us 1352 kilojoules to break those bonds in the tetrachloromethane to end up with our gaseous atoms. But now you see we've got a full cycle apart from what we don't know. Okay, so now it's just a question of working it all out. Let's change color again. Let's see what. Let's do white. Now we're going from here to here. Okay, but we can't. That's the one we want to know. But we're going to need to go round the other route because the other ones are the ones we know. So we're going to go down here, up there, and along there, and finish up in the same place. Okay. So as we go that route, we're going to go with this arrow. Okay. So that's it's going to be 1. So our delta H formation of tetrachloromethane is with this arrow, so that's 1199. We're going with the arrow, and it's a positive number, so that's that. And then we're going against this arrow, right? So we're going to say minus our 1352, right? Because we're going against the arrow, and in this direction, in the direction of the red arrow, it's a positive number because that's That's bond breaking, which takes energy, which is endothermic, which is positive. Okay, and likewise, we're going against this second red arrow right here, right? Our red arrow is going in that direction because we're starting from a liquid and vaporizing it into a gas. All right, and if we go the other way, we get we have to minus the 31. Okay, so it's minus because it's against the arrow. It's plus 31 because bond breaking, boiling it off is endothermic. All right, so there's our sum, and that comes out to be minus 184 kilojoules per mole. Like so. So hopefully that's answered your question. Let me know otherwise.